going to install a probe into some blackberries now, which are potted, as you can see. So the number of things we need to think about. We need to ensure the pot is representative of the rest of the block. So looking at this plant, it looks pretty good to me. It's pretty representative of what we've got down the row here. There's a plant over to my left here which is slightly weaker, so this would not be a good pot to go into. Wouldn't be particularly representative. We're midway down the glass house. We're not at the end, we're not right in the middle, we're about halfway down, we're a quarter way down the full length, so this is a good representative area to install the probe. We use a drill like this for installing into pots. We simply drill a pilot hole like so. And it's important to get the pilot hole in a representative area or in a wetted area. We've got a dripper here, we've got a second dripper over here. We're just slightly closer to this one and the second one. We're definitely in a wetted area of the pot. This should give us good data in terms of how the pot's drying out and wetting up from the irrigation. So having drilled the hole, we'll now insert the probe and connect to it. Make sure we've got good readings, just as we've done with the strawberries in the trough. And we can then reprogram the logger and make sure it's ready to function and send data back to the server. Okay. So here's our probe. Before we set the electrics up all nice on the metal post here, we'll install the probe first to make sure we can actually get it in nicely and check the readings are good. Otherwise, if we fix this up first, we've simply got to take it back down and move it. So I go to my pilot hole and try and push straight down without disturbing the core in the pot too much. And I'm exerting a reasonable amount of pressure on there. That's as far in as it can go. I'm just selecting the core at the top of the hole there, so that we don't get water running down the side of the probe. And that now ought to give us good readings. Having installed our probe now into the pot, we're now going to go and check that the readings are okay and make sure the settings are all correct in the probe and the probe electronics. So we click on the probe configuration utility program. So long as you've got a COM port highlighted here, you'll be able to connect. So I'm going to click connect and you'll see we're now connecting to the probe. What I'm going to do is to straight away go and do a sensor test by clicking on the sensor test tab and clicking on query all sensors. These are the sensors that are recording moisture. Also on this drill and drop probe there are sensors recording temperature too, so this is temperature in the coil. But the top four readings of moisture are 0. That's because the probe's sticking out of the pot, simply measuring fresh air. You see the fifth one's just dipping into the coil, picking a bit of moisture up. But down at the bottom, this is what I'm expecting to see in a pot the size we've just installed into. A good moisture reading here. That means we've successfully installed the probe into the coil, not disturbed the coil too much down at these depths. So having checked all of that, I'm going to move on to the clock. You will need to synchronize your computer with the probe when you first receive the probes and install them, because the clock won't be correct. So I'm going to click on synchronize. Having done so, you will see the date and the time text here is now in red rather than black. That's because it's prompting me to save the change, and to do that I need to click write to probe and then click OK. Now they've gone back to black, so I've now set that. We've changed the time and date on the probe itself. This box here should never be touched. It should always be 30 minutes in here. What this is actually doing is it's telling us the interval of which the probe is actually logging a reading. That's not sending the reading to the server, it's actually logging the reading on its inbuilt data logger. So every 30 minutes it's logging a reading, and that's what it should always be. Moving on to the logger tab, logger ID here, this is the point where we can actually put in the name of the block you're measuring from, so you can recognise where your data is coming from. So if for example it was block 1 strawberries, we could type in here block 1 straws. I suggest you always do this in lowercase, never put any spaces in. All this is simply doing is giving the actual probe a name so that I can recognise it when you send the data up to me, and you can recognise it.
So you'll see now again we've made a change. It's now red rather than black. To save that change I've got to write that to the probe, click OK. That's now successfully changed the name. If you were to move this probe during the season, you may take it out of a block of strawberries for example and insert it perhaps into a block of raspberries. When you reinstall it, always rename the logger ID to the name of the new block so we can differentiate the data in the database. The only other thing that may need changing from time to time down here is this sample count and this number 1. Now what this means is that every 30 minutes one reading is being sent to the server, and that's as fast as we can get these things to upload. So if you're managing a block of substrate, the more frequently you can have access to up-to-date data the better. So this is sending every 30 minutes. What that means is every 30 minutes the modem's getting woken up by the probe, and the probe is asking the modem to send the data to the server. This is the biggest drain on power, modem actually sending data. You may find in the winter months, we certainly do at times in the UK with our poor light levels, we may find that's a big drain on the battery. So to conserve battery in the off season we can increase this number, and by doing so you'll notice now the readings are now being sent every 2 hours rather than 30 minutes. So the modem is working, if you like, 75% less than it was originally. So this is a good way of conserving power if we need to, and clearly if we wanted to save the change we click write to probe. I don't, because I want to send readings every 30 minutes. This is the default setting that you'll find on your probes when you receive them from us. Moving on from here we can click on to network. The only boxes that will need to be changed here is this username and password. This is the username and password of your local carrier that's to enable you to access their GPRS network. In the UK we use Vodafone. Vodafone's username and password are the same, it's web and web. Your network carrier will have its own individual usernames and passwords. They may have none at all, but we need to know that so we can get these boxes filled in correctly. Without this being correct, you won't be able to send data through the network to our server. Moving on to modem. Now the modem page here we can perform a number of tests. When you've just received your probe there's clearly no data on the data logger. So the only test you can perform is a test, and by clicking this box here it will send a test text message up to our server. That then means that we know that we're able to receive information from that probe in your field. The upload button, the occasion you may use that is if, for example, network coverage has been lost for a few days due to varying reasons. The probe will carry on logging data and storing it. It's got a data logger with about a 7 to 10 day memory. So when the network comes back online, if you wanted to force an upload, you would use this upload facility to force that 2-3 days worth of data through. For now I'm just going to click a test because this is connected to a new probe, no data on it, so I'm going to click this test button and this will run through a series of commands, and there will be a certain message that we want to end up with seeing. This might take 2 to 3 minutes, so I'm going to let this thing carry on running whilst I move on to the power tab, which it's not going to let me do because I've now locked it up. So I'm going to cut the video and let it run its course and then restart it once I've got the message I'm looking for. So the test process is finished and the message that I'm looking for is 040 success. So long as you see that, you're guaranteed that you've sent that information successfully and it's reached the server at our end. Lastly, the power tab here, this is advising you what voltage you've got in your battery at the moment. Right here and now there's 11.7 volts. So a battery fully charged is about 12.7 volts, but there's ample power in this battery at the moment to carry on powering up the system. Effectively, the telemetry of the modem will stop working when the battery voltage drops to 10 volts, and the probe will stop logging data when the battery drops below 4 volts. So we're well beyond these voltages at the moment, so although it's not fully charged, hopefully the solar panel If we get some good light days, we'll pump some power back in and fully charge the battery back up again. That's basically it. We've now tested everything, we've made sure our settings are correct. We can now disconnect from the probe. We can disconnect the comms lead, reconnect the little moisture cap, dust cap back onto the drill and drops electronics, tidy the electronics up, and the site can then be left. Last thing, remember, ensure that power switch is on the underside of the enclosure.